Question 11, we got large data set. Woohoo. So, the pre-release material contains data concerning the death rate, happy as always in statistics, per 1,000 people, and the birth rate per 1,000 people in all the countries of the world. The diagram in figure 11 was generated using a spreadsheet and summarizes the birth rates for all the countries in Africa. Part 1 wants us to identify two aspects in which the presentation of the data is incorrect. Okay, so nowhere on the y-axis does it say per 1,000 people. So I would guess what we are going for here would be a histogram, not a bar chart. So first of all, the y-axis should be frequency density. Now, if we're drawing a histogram, the bars should be next to each other with no gaps, so they should be touching. We should have a continuous scale going along the x-axis, not these intervals. The intervals should also not have no upper bounds, so they should have upper bounds. We've got different sized intervals. See here we got 10, 2, and then 22, 0 to 10. A lot of these are 5s. So the bars should be different widths to represent different intervals. Any of those, any two of those, and we're cool. Okay, next up, figure 11.2 shows a scatter diagram of death rate Y against birth rate X for a sample of 55 countries, all of which are in Africa. A line of best fit has also been drawn. So we got a scatter diagram of death rates against birth rates in African countries. So death rate is on the y-axis, birth rate is on the x-axis. We are told that the equation of the line of best fit is y equals 0.15x add 4.72. Part 2a asks, what does the diagram suggest about the relationship between death rates and birth rates? Okay, so we can see that there is positive correlation between birth rate and death rate. Now, it's quite gentle positive correlation. The gradient is only 0.15. So, I guess we would say something like there is very weak positive correlation between birth rate and death rate. So, as birth rate increases, so too does death rate. Okay, then for part B. The birth rate in Togo is recorded as 34.13 per 1,000, but the data on death rate has been lost. Use the equation of the line of best fit to estimate the death rate in Togo. Okay, so remember that Y is death rate. So for this, all we need to do is Y is 0.15 times 34.13 and 4.72. And for that we get 9.8395. Cool. Okay, then part C wants us to explain why it would not be sensible to use the equation of the line of best fit to estimate the death rate in a country where the birth rate is 5.5 per 1,000. So that probably comes down to the graph then. So 5.5 is going to be about there. First of all, we can see the line of best fit isn't drawn for that part, and the reason for that is there is no data in that region. So that would be our reasoning. There's no data in this set to use as an estimate in this region for 5.5. But D wants us to explain why it would not be sensible to use the equation of the line of best fit to estimate the death rate in a Caribbean country where the birth rate is known. So all of our countries in this scatter diagram are in Africa. The Caribbean is not. So that would be the reason for that. Okay, then part E wants us to explain why it is unlikely that this sample is random. So there are obviously more continents in the world than Africa. All of these countries are in Africa, so it's incredibly unlikely that this is a random sample from all countries in the world, because these are all in Africa. Okay, then for part 3, including Togo, there were 56 items available for selection. We want to describe how a sample of size 14 from this data could be generated for further analysis using systematic sampling. So the one that always comes to me first is random number generating. Assign each country a number between 1 and 56. Set up a random number generator to generate numbers between 1 and 56. Obtain 14 distinct numbers and then select the corresponding country. Here as well, 14 is a quarter of 56, so we could just select every fourth country if they are all in a list. That would work too. Cool.